Hey everybody, so here is a little information about the lesson 2 Ready Set Go. The first couple problems look something like this, and they ask you to use the coordinate grid to find the length of each side of the triangles and give the answer in exact form, which just means if you end up with a square root of 29, you just leave it as a square root of 29 instead of changing it to, what would that be, 5.43 dot 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 something. Okay. Okay, so let's look at this first triangle. Obviously, 1, 2, 3, this is 3. 1, 2, 3, 4, 5, 6, 7, that's 7. And then it's just a Pythagoras. 3 squared plus 7 squared equals c squared, because here's the 90. So here's the long side. The long side is c. Set up the pattern. And we get this. This isn't exactly problem number 1. This is just an example of what problem number 1 is like. And then we're going to change to this weird green color for my square roots and back to red, and that's the answer, square root of 58. And there's a problem later like this, and what I want you to do here is think about the fact that if you, maybe that's a right angle, but then like how, there's some, this is 1, 2, 3, 1, 2, 3, 4, 5, 6. That's 6, so we know that, like, but also these are the same length, so 2 of the mystery length squared equals 6 squared. That's one way to do it. Where did I get 2 of the mystery length? Well, it was question mark squared plus question mark squared equals 6 squared. But now I have 2 question mark squared, so that's 2 question marks squared. And you could solve that. Or, oops, I'm just going to leave it. Pardon me. Okay. You could you could set up a new triangle here, and that's a 3 by 3. So now you can do this. C squared, where C is this side here. And you can do it again for this side, and then do another round of Pythagoras and get that side. That sounds fun to me. All right. Again, that's not exactly like the problem in the book. I switched it up a little bit. Then we get to the set, and they ask you to write an equation for the line and make a new line that's parallel to it. If it's parallel, you'll have the same slope. Parallel, same slope. We learned yesterday that perpendicular has an opposite reciprocal, but parallel has the same. So let's count the slope on this thing. Go somewhere on the grid where it touches the grid, like here. 1, 2, 3, 1. That was rise 3, run 1. That's the slope. And here's how you write an equation. You write y equals the slope times x plus, or in this case minus, because the y-intercept is down at -1, -2, -3, -4, -5. So it's the slope times x plus the y-intercept. And if the y-intercept's negative, then it's minus. That's it. Hopefully you learned that last year. So what if we wanted a parallel line? Well, we just grab the same slope, switch colors to orange. We want the same slope, which is 3, and we just pick a new y-intercept. How about plus 1? So now I'm going through here. 1, 2, 3, 1. 1, 2, 3, 1. Down 1, 2, 3, back 1. And voila. The next section asks you to write the equation. So the slope on this thing is 1, 2, 3, 4, 5 over 1, so 5. And its y-intercept is actually at 0. And we want a perpendicular slope. Or sorry, we want a perpendicular line. So we flip it over. If this line's going up really fast at 5 per 1, we want to actually go down slow at 1 per 5. And we can pick a new y-intercept. Let's just pick 2. Down 1, forward 1, 2, 3, 4, 5. If you hear my kids yelling in the background, they're sick now, so they're cranky. Ta-da! Perpendicular. Okay. The last section has these multi-step equations. The name of the game is get all of the x's onto one side, all the other numbers onto the other side, and then solve it from there. There's going to be distributing. I just randomly picked these numbers, so this problem may not turn out very nice, but let's just go for it. Notice how this side didn't change at all. You just have to rewrite it. There's going to be rewriting. Okay, now let's decide. Let's take the 4x's off this side, and we get those are gone. We get the negative 12. Got the 2x plus 9. Let's get the 9's off this side, and we got negative. What is this? 21. Okay, this isn't the worst problem ever. So all the x's are on the right. The regular numbers are on the left. We're dividing. I get negative 10.5. Ta-da! All right. And yep. Okay. You guys, I believe in you guys. You got this. All right. We'll upload that lesson maybe tomorrow. Do homework due tomorrow or tonight. Well, I'll put it up today. You can upload it as soon as you're done. All right. Have a great day. I'll see you later. Bye.